Hello students, today we are going to learn about the arithmetic mean, which is one of the most important measures of central tendency in statistics. By the end of this session, you will understand three different methods of calculating the arithmetic mean: the direct method, the assumed mean method, and the step deviation method. Let's begin. The arithmetic mean, often called the average, is a single value that represents the entire data set. It is obtained by dividing the sum of all observations by the total number of observations. In simple words, it tells us the central value around which the data tends to cluster. Now let us understand this using group data, where values are given in class intervals with frequencies. In the direct method, the formula is mean equals summation of frequency multiplied by midpoint divided by total frequency. We are given this table: class interval 0 to 10, midpoint 5, frequency 4. Class interval 10 to 20, midpoint 15, frequency 6. Class interval 20 to 30, midpoint 25, frequency 10. Class interval 30 to 40, midpoint 35, frequency 8. Class interval 40 to 50, midpoint 45, frequency 2. The formula is x bar equals sigma fx divided by sigma f. From the table, the sum of fx is 730 and the sum of f is 30. Now we substitute these values. X bar equals 730 divided by 30. That gives 24.33. So, by the direct method, the mean of this data is 24.33. The assumed mean method helps us simplify calculations. The formula is mean equals assumed mean plus summation of frequency into deviation divided by total frequency. Here, we take assumed mean as 25. For class interval 0 to 10, deviation is 5 minus 25, which is minus 20. Multiply with frequency 4 gives minus 80. For class 10 to 20, deviation is 15 minus 25, which is minus 10. Multiply with frequency 6 gives minus 60. For class 20 to 30, deviation is 0. Multiply with frequency 10 gives 0. For class 30 to 40, deviation is 10. Multiply with frequency 8 gives 80. For class 40 to 50, deviation is 20. Multiply with frequency 2 gives 40. Adding all these, summation of frequency into deviation is minus 20. Total frequency is 30. Therefore, mean equals 25 plus minus 20 divided by 30, which is 25 minus 0.67. This again equals 24.33. The step deviation method is even easier when class intervals are equal. The formula is mean equals assumed mean plus summation of frequency into step deviation divided by total frequency multiplied by class width. We again take assumed mean as 25. The class interval width is 10. For class interval 0 to 10, step deviation is 5 minus 25 divided by 10, which is minus 2. Multiply with frequency 4 gives minus 8. For class 10 to 20, step deviation is minus 1. Multiply with frequency 6 gives minus 6. For class 20 to 30, step deviation is 0. Multiply with frequency 10 gives 0. For class 30 to 40, step deviation is plus 1. Multiply with frequency 8 gives plus 8. For class 40 to 50, step deviation is plus 2. Multiply with frequency 2 gives plus 4. Adding them all, summation of frequency into step deviation is minus 2. Now substitute mean equals 25 plus minus 2 divided by 30 multiplied by 10. This is equal to 25 minus 0.67, which again gives 24.33.